So we're going over the origin of life, 3 proteins, form and function worksheet. That's plenty to say. So let's get started. I know some people are having some difficulty with this, so I wanted to make a little bit of a review video that might help us. Okay, so we're dealing with proteins. Now proteins, of course, another fancy word for is polypeptides. It's a polymer of amino acids. So we're going to identify all the peptide bonds, which means all the linkage or the links between the amino acids. Now we put in our activity amino acids together to get this primary structure. So we should be able to go backwards. For those that are having trouble, think what a primary structure is in terms, or think about, your amino acids that you started with. So let's do that. So let's take a very simple amino acid. Let's take the basic structure. Let's take that Q group, or that carboxylic acid, with an OH, and then we have this bonded to another carbon who is bonded to an R group, as what we like to say, A group, and this goes to a nitrogen bonded to an H to another H. Okay, now this is going to bond to another amino acid. Let's be crazy and change the color up. Now it's important though, they have to collide with the proper orientation. So this amine or amine group at the end, all right, is bonded to this carbon who is bonded to the A group. That makes it unique. And then of course you've got the carboxylic acid, all right, ending. And it's important to realize that we're dealing with the amine ending and the carboxylic acid ending, and these guys come together, and what are they going to make? Well, the H and the OH, okay, come off to make water, as you guys did in the activity, and you push these together, and when you push them together, you're going to have this N with bonded to one H, because we lost the other H to water, so I'm just kind of moving this up. It can rotate. And then it's bonded to a C group, is bonded to that R. We still have our carboxylic acid ending. That didn't change. What did change was this amino acid. Let's make it A. This, I guess, B. And what happened here for this amino acid is that we lost the OH. So we have a bond to this carbon who's double bonded to the O, who's bonded to another carbon who's bonded to the R, and then kind of go down here, N, who's bonded to two H's. So my peptide bond in all of this is between the double bonded O to the C, that's the carbonyl group, and the amine, or what was once the amine group. So this is my peptide bond. And if you can visualize that, okay, that we're dealing with the carboxylic acid and the amine group coming together, then we look at our look at our primary structure, we can see the double bonded to the O and the N. So this is our peptide bond. That's what we put together, assuming water came out. And go find another one. And there is another. And then there's another. And what you're starting to see, if you can put that together, and I don't want to do all of them, is that you should be able to see that this, no, not good. You should see that this, all right, is the ending of the, this is one group here, easy for me to say. Here is the start of another amino acid. Okay, we're getting crazy here. And let's go in a different color because I can. And let's go here as the other. And you can see that what I'm doing is I'm showing you where the amino acids are. And in between all of that business is we have the peptide bonds. So that's the amino acids. Notice the R group is on the what? That second carbon in between the others. So you should be able to put that together, okay? Understand, we put these links together with the activity. Should be a lot easier to keep looking and keep going down. So that was one issue people had. Some people had issues with figuring out which kind of R groups can hydrogen bond. All right, well, The R group second hydrogen bonds are the ones that are polar. Like for instance, if you look carefully here, we have an OH group. Okay, if I blow this up, you have a O bonded to an H. And we had a lot of fun today in school. We learned that anytime a hydrogen is bonded to an oxygen or a fluorine or a nitrogen who is so very electronegative, he pulls that pair of electrons toward the oxygen. So what we have is an electron deficient hydrogen that's positive. And that allows this positive to bond to other negatives. So this is a negative, little positive part. So this, essentially what I'm asking, if you find something that's polar that doesn't have a charge, okay, it's essentially going to be able to hydrogen bond. Okay, continuing on. All right, in this one I was asking you to find where the hydrogen bonds would occur in a secondary structure. And what I'm looking for is for you guys to draw me some dotted lines between a what? Between a electron deficient hydrogen. Anytime a hydrogen's bonded to an N or an O or an F, we have one. Here it is. So this is a plus little proton, and he's going to be attracted to anything that's negative. And what's going to be negative is going to be a very electronegative O, N, or F. They have electron-rich area, so he's going to be attracted to that. This H is bonded to an N for the same reasoning, and it can make a hydrogen bond, which is really attraction. This is not an electron deficient H. Although it's an H, just because it says H bonding, don't fall in love with that. That just means that a hydrogen, as we learned, is essentially the same as a carbon in terms of its difference in its ability to attract electrons. So between the carbon and the hydrogen, these electrons are shared almost down the middle, so that doesn't make this electron deficient. So the proton in the hydrogen is still attracting this pair, so it's busy doing so, so it's not going to H bond. So don't fall in love with the fact that all H is H bond. Only ones that are what? Bonded to an N, O, or an F. So you can see that this fits that category. This fits that category, okay? And this does not, okay? So you can keep going and find those attractions, all right? Now as we go down to a tertiary structure, we should be able to identify these types of attractive forces. And then as we go into the last page, people really had some trouble here. I was asking people to put these together. Number 14 says, what type of bonds and interactions hold the quaternary structure in place and label? So 14 was about just labeling these guys, had nothing to do with this picture down below. These pictures here, I want you to bond together. So what you're going to do is you're going to take the amine group and react it with the carboxylate acid group. Okay, don't forget something is going to come off. It's a dehydration reaction or a condensation reaction. And then you're going to put them together. So you're going to put these amino acids together into a polypeptide with the right number of water molecules. Think about what we did actually in our activity. We actually cut some of these off, made the waters, and if you took part in the lab, this should not be a problem. Okay, I kind of walked you through that with the first page. Okay, so hopefully that is not a big deal for you, and hopefully you can look at the key that I have posted to see if in fact you did it okay. So again, if you're having trouble with number 15, rewind me to the beginning part where I actually started putting molecules together. All right, hope this helped.